everyone. I am Ruchi Jain, Assistant Professor from ABES Engineering College. Today, I'm going to discuss with you the topic RAID, which is from operating system. Here is the outline of the topic. In this video, we will cover the topics which are as follows: RAID, why we use RAID, key terms in RAID, various RAID levels like RAID level 0, 1, 0, 1, 3, 4, 5, 6. So here's our first topic, that what is the RAID? RAID is What is RAID? RAID is a full form of word RAID is redundant array of independent disks. RAID is an RAID is a RAID full form of RAID is redundant array of independent disks or drives, also known as redundant array of inexpensive drives. Various type of RAID are data storage schemes that divide or replicate data among various hard drives. Like in real world scenario, if there are various data that are stored in a drive, like there is a drive where we store the data, then we required to store this data to some other places which act as an independent disk or independent drive. This process is known as RAID. RAID is a way of combining several independent and relatively small disks into a single storage. Like there are various disk storages or various small disk storages. We combine all these storages to make a single disk storage. This is also comes in RAID. The disk can combine into the array in different ways, which are known as RAID levels. Why we use RAID? Because RAID is used to improve the reliability of our system, to improve the performance of accessing the drives. There is a scope of fault tolerance. Like if there is any fault occur, then how we can tolerate, or how we can recover our data from any fault that is arises during the accessing of any disk. Improve availability. Improve availability means if we want any data at that particular time, we get that data at the same moment of time when we requested that data. And high data security means that data has been secured from the intruder in a very efficient manner. There are various terms that are used in RAID. Are the first term is mirroring. Mirroring means copying of data from one drive to many other one or more many drives or disk. Stripping means splitting of data across one or more disks. Like there is a data, like there is a like there is a data over here, like if A is a data, then that data is divided into A1, A2, A3, A4. Then this is known as stripping of data. Parity means, as you all know, that in networking, in data networking, when data is stored in the drives, then the parity of that data makes that data is protected from the intruders. And if we want the full set of data from all the duplicate drives, then we have to check whether the data that we are retrieving is good or not by checking the parity bit of that data. Duplexing, it is an extension of mirroring that is based on the same principle. So as that the technique expect it to goes from one step further, that it can also duplicate hardware that control two hard drives or set of drives. There are various RAID levels, which are as zero level, which is also known as stripping the array with no fault tolerance. That Second is data disk mirroring. Third is parallel accessing array with dedicated parity. Level 4 means is stripping data into independent disk and dedicated parity disk. Level 5, stripping array with independent disk and distributed parity. Level 6, stripping array with independent disk and distributed parity, and combination of various levels, or you can say the nested levels. These are the various levels that we will further discuss in this video. First is RAID 0. RAID 0, or you can say that level 0. In RAID 0, the stripping of data is done with the help of at least or minimum two disks without the parity. Like you are here, you can see that here you can see that there is a data of a module A. That A module is divided into A1, A2, A3, A4, A5, A6, A7, A8. That means data are stored in different. The data A is divided into 8 modules, and all eight modules are stored in two different disks, disk 0 and disk 1. In disk 0, we have A1, A3, A5, A7, and in disk 1, we have A2, A4, A6, A8. By breaking the data into different blocks, and each block is divided are stored in separate disks. By this method, we can best we give performance of our this accessing is increases, as if one user want to access A1, then he had to fetch the data from disk 0, and if one want to access A4, then he or she get the data from the disk 1. By this, we have multiple controllers that are used, and one drive per controller. By this, we increases the performance of our disk. So these are the various benefits of RAID 0, like best uses of the space, and if every byte of the disk can be accessed in an array, very fast reads and writes, and simple design and operation. Various limitations of RAID 0 are like there is no redundancy, no for use in mission critical system. One disk failure means all your data is unrecoverable, because there is no duplicacy or no mirroring. No, because there is no mirroring or no copies formed for the data that are stored in different disk in RAID 0. Now here comes the solution for RAID 0. There is RAID 1. RAID 1. What is RAID 1? RAID 1 is called mirroring. Mirroring means the data that is stored in one disk is duplicated or mirrored in another disk. Like here you can see in the diagram, there is a data A1 in disk 0 that is replicated in disk 1. A2 is replicated in disk 1 again, and A3 is also replicated in disk 1. A4 is replicated in disk 2. This means that all the data that are stored in disk 0 are get replicated in disk 1. By this, if any disk failure occur in disk 0, then we get the data recovered from the disk 1. So here the problem of the disk 0, that is of fault tolerance, is get recovered from this in RAID 1. So here are very various benefits of RAID 1. Good redundancy, fast read, you can read two block at a once. Writes are acceptable, and no intense calculation on rebuilding, just copy. You have to copy the data of A1 of disk 0 to disk 1, A2 data of A0 to of disk 0 to disk 1, like here in this previous slides, you can see that A1 is get copied to A1 of disk 1, A2 of disk 0 is copied to A2 of disk 1, and so on. But there is a limitation problem. Limitations is a space problem. Like you have to replicate all the data of one disk to the another disk as it is. So here is a space problem, and writes are not as fast as other rate types and very expensive, because you have to copy all your data into the another disk as it is. So due to which this RAID 1 is very expensive, as more disks are required for your data to get stored on RAID 1 level. Now here comes the nested RAID. Nested RAID combines the performance benefit of RAID 0 and redundancy benefit of RAID 1. It uses both stripping and mirroring technique. It requires an even number of disks, minimum being 4, or you can increase increase the number of disks from apart from 4, offer identical benefits, and rebuild operation differ in both. Here is an RAID 10. Here you can see that here is a RAID 1, RAID in 10. In RAID 10, we get the get the advantage of both RAID 0 and RAID 1. As you can see in the lower level, we get RAID 1 like mirroring. In this, A1 is replicated in A1 of this one, A3 is replicated as A3 in this one, A5 or this 0 is replicated in A5, A7 is A7. And similarly, they utilizes the benefit of RAID 0, like we do the data to be stored in stripped manner like A1, A2, A3, A4, A5, A6, A7, A8. By using RAID 10, we are getting the advantage of both the rates of RAID 1 and RAID 0. In this method, if any disk is failed, like disk 1, A5 or disk 1, A5 of disk 1 is failed, then it get recovered from disk 0. Or you can say that if A2 is failed from disk 2, then it is recovered from A2 of disk 3. So recovery of the data is going to occur in a very efficient manner, and data is mirrored by which uh, data recovery or data rebuild is able to done by using RAID 1 and 0. Application benefits of 10 are it is used in high transaction rate online transactional processing, like online banking system. You can use RAID 10. Large messaging installation, database application that require high input output rate, random access, and high availability, like all the real time applications that are uses efficient uses of database are using RAID 10. Here comes another level, RAID 3. RAID 3 is also known as bit interleaved parity. In RAID 3, we get an additional disk, which is we get an additional disk. We get an additional disk which store the parity of all the levels. Like A1, all the data are stripped in byte format, in byte level. All the data are stripped in byte level. All the data get stored as A1, A2, A3, A4, A5, A6, B1, B2, B3, B4, B5, B6. All the parity of A1, A2, A3 are stored in the parity disk of AP1 to 3. 4, 5, 6 parity is stored in a lower level. B1 to B3 parity is stored on other lower level. B4 to B6 is stored in other lower level of disk 3. By using the parity, the benefit of parity is that if A2 is get failed, now what we have to do? When A2 get failed, not so we can recover the data of A2 by calculating the data by using this parity bit. From the parity, we can recover any of the disk data that get faulty or that get damaged. And performance is high because we are stripping the data, and fault tolerance is improved because of the parity. RAID 4 is similar to the RAID 3, but with the difference that data is stripped in the block level. Block level, all the data is stored in the blocks, and A1, A2, A3 parity is stored in AP. B1, B2, B3 parity is stored in BP. C1, C2, C3 parity is stored in CP. D1, D2, D3 parity is stored in D3. But there is a limitation of both RAID 3 and RAID 4, is that if this disk 3 is get if this D3 is get corrupted or failed. If this D3 is get corrupted or failed, and on simultaneously this A3 is get failed, then you cannot recover this A3 because parity disk is also get failed. So this is the drawback of RAID 3 and RAID 4, that all the parities are stored in a separate disk, and when this disk is get failed, you cannot recover all the data that are stored in other disks. Advantage of RAID 4 are high read rate, low rate of error correction, and can recover from single disk failure. Now here comes the RAID 5 level. In RAID 5 level overcome the problem that is occurred in RAID 3 and RAID 4. In RAID 3 and RAID 4, the limitation is that parities are stored in a separate disk, and when the disk gets failed, you cannot you cannot recover the other disk data. But in RAID 5, the parities are stored separately. All the blocks parity are stored in separate disk. Like for A blocks, the parities is stored in A3. For B blocks, the parity is stored in B2. For C blocks, the parity is stored in disk 1. For D blocks, the parity is stored in disk 2. So like if we can say that if this block get failed, but there is a chance that you can recover the B3 by using this, C3 by using this, and D3 by using this. And as you can calculated all the other data, you can also created the parity for A block by getting all these data recovered from other parities. Benefits of RAID 5 are read rate the same as RAID 4 because parity bits are distributed. Even write does not need to access a single disk. Like RAID 4, you need relatively little parity which allow the larger arrays. Next level is RAID 6. In RAID 6, all the limitations of all the levels are rectified in RAID 6 level. In RAID 6 level, as all the data are stored in various disk 0, disk 1, disk 2, and all the parities all as in the previous level. If only one disk is failed, then it get recovered. But if there comes that you get lost data of two disks like A1 and A2, now what you have to do, because if there is only single parity, then you can get the data retrieval from only one disk. But here there is a problem that you have get failure of disk of A1 and A2. If there is only one parity, then this recovery of A1 A2 is not possible. But in A6 there is two parity, AP and AQ. By AP and AQ, AP and AQ. By AP and AQ, you can by these two parity you can get A1 and A2 by using the formula like in maths. If there are two variables and two equations, then you can retrieve the value of of both the variables by using two equations. By these two equation method of maths, you can also get the data retrieval of A1 and A2 by using two parity AP and AQ. Implementation require at least four disks because A1, A2, A3 are three disks from where you are doing the stripping, and uh, and uh, like data at least four disks are required because if there is a data A, it gets stripped at least in two disks, A1 and A2, and two parities, AP and AQ. So by this you can say that for implementing the RAID 6, you required at least four disk. Distribute the parity across the disk. As you will see that parities are not stored in the last disk. All the parities are distributed among all the disks. Like for A block the parity is disk 3 and disk 4. For B block the parity is in disk 2 and disk 3. For C block the parity is in D1 disk 1 and disk 2. For D block the parity is D0 disk 0 and disk 1, and so on. The writing penalty is more than in disk 5. The rebuild operation may take longer because there are two parities, so we have to rebuild the data by using the two equation method, which take more time as compared to RAID 5 level. Here are the textbook from where you get the reference of the data that are you in this video. Here the disclaimer of the video. Thank you.